So hopefully by now you feel pretty comfortable completing the square and also factoring those using that trick that I taught you by halving the coefficient of the non-squared variable term. So let's go on to the next section, and now we're going to start making some graphs. So from this point on, throughout the rest of the unit, I'm going to not only be encouraging you to work with functions and to solve functions, but also to graph them. So let's look at this quadratic that's in a slightly different form than what you've seen up to this point. So number one, let's do a different color than that. Number one has y equals x minus 3 squared plus 2. Now this is a quadratic. This is still a quadratic function, but it looks a lot different than what we've been working with in class. So what you've seen in class are functions that look like this. And remember, there's a specific name that we call this form. Do you remember that name? So hopefully you remember that functions that have this form, we say, are in standard form. So this is standard form. Standard form. Now where we're headed with this lesson, we want to take expressions or functions that are in standard form and rewrite them to look like this. And this form we call vertex form. So when you have forms like this, we call that vertex form. Vertex form. So the whole goal is to be able to rewrite expressions that look like this in standard form in vertex form. And I'll show you why that's useful. But let's just go ahead and test this. Let's make sure that this is indeed a quadratic, because if it is a quadratic, then we should have a shape that looks like a parabola. You guys have seen those. So we have functions that look like that, and we call those parabolas. And we want to make sure that this function still makes a parabola. So let's do that. Let's make a graph of this function, number one, by plotting it. Now, what I recommend is opening up Metamoji Note, and there's an option to select different paper styles, and you can select the graph paper. That'll help you plot your functions, and I'll go ahead and go to page 2 here to show you what you're looking for. So you're going to want something that looks like this. So some graph paper to help you plot these functions. But before we do that, let's go ahead and make a t-chart. Now you guys have probably done this before in coordinate algebra, and it's going to be the same here. So I want to make a t-chart and basically just get a bunch of different points that I can plot to construct my graph. So we make our t-chart, we'll pick some arbitrary x values. So x here is going to be the same as this x. So these are going to be our input values, and you can basically just choose whatever you want to go here. It needs to be a pretty good range of numbers, and then we plug these numbers into the function and solve for the corresponding y numbers. So after we select our x values, we will calculate our corresponding y values, which are the output values of the function. So go ahead, get out a sheet of paper and construct your own t-chart. It really doesn't matter if it's the same as mine. In fact, I hope your data points are not the same as mine, so that way you can combine your data points with my data points and get a really, really nice graph. So here's our t-chart. Go ahead and construct one yourself and see what you get. Now for my t-chart, I'm going to start with, just going to pick -1, -1. And what I do with this value is I plug it in to this function, so that way I get -1 minus 3, all of that squared, plus 2. And when I plug that into my calculator, I get a y value that is equal to 18. And then I pick another number. I'll just pick 0 here. Now, I plug 0 in for my x. I get 0 minus 3, that's -3 squared. -3 squared, that's 9. And 9 plus 2, that's going to be 11. So I get 11 here. And then I do the same for 1. And we'll do 3. And let's say 5, 7, and 9. And when I plug each of these values when I plug in 1 in for x, and then plug this into my calculator and solve, I get 6. I get 6, so 1 and 6. I plug in 3 into x and solve for y. I get 2 here. And then I plug 5 in for x, and I get 5 minus 3. That's going to be 2. 2 squared, that's 4, plus 2, that's going to be 6. So our 6 shows up again. And then 7, plug 7 in. 7 minus 3, that's 4. 4 squared, that's 16. Plus 2, that's going to give me 18. And then finally I plug 9 in for x, and when I plug that into my calculator and solve, I get the number 38. So these are our data points. So now I want to go to a graph and I want to plot all of these points. So I've got -1 on my x-axis and 18 on my y, 0 on my x, 11 on my y, and so on and so forth. Now I want to plot each of these data points and then make a graph and see if it looks something like this. So remember, we're looking for a shape that looks like a parabola. And if it looks like a parabola, then we can say that, yeah, this is definitely going to be a quadratic. It's just in a different form. It just looks different than what we're used to seeing. So go ahead and give it a shot. Pull up Metamoji Note, open up the graph paper, not the blank page, and make a graph. And then come back to this video and compare your graph to my graph. So hopefully you finished your graph, and I'm going to walk you through how I made a graph. Now I'm going to go to the next slide, and I've already got some graph papers set up here, and I've copied our data over here in the left-hand corner just to give us, or to make it a little bit easier for me to show you how I made this graph. Now I went ahead and set up both of my axes, so down here is my x-axis, and up here is my y-axis. And if I want to plot the very first point, which is -1, 18, I first find -1 on the x-axis. So here's my -1. And then I go and I find 18 on my y. So here's -1, 2, 4, 6, 8, all the way up to 18, which is right here. So I'll make a point there. So that's one point of my graph. Try to make that a little thicker so you can see it. So that's one point of my graph. Now I find 0, and then I scroll up to 11 and put a point there. So here is 0 on the x-axis, and I go up, and it's going to be between. So this is 12, 13, 14. So my 11 is really going to be down here, somewhere like below this 12. So it's going to be in between 10 and 12, so 10, 11, 12. So I'll go ahead and put it right in between my 10 and my 12. So 11 is right around in here. Now my next point, 1 and 6, so I find 1 on my x-axis and then go up to 6. So there's my next point, 1 and 6. And then I find 3 and 2, scroll over, find 3, and go up to my 2, which is going to be right here. And then I go to my next one, so 5 and 6. So 5, go up to 6, it's going to be right there. And then we plug in 7 and 18. So I find my 7, go up to my 18, which is right there. Alright, right there's my last data point. I'm not going to do the 9 and 38 because the 38 will be off this axis. So I'm just going to scratch that data point, which is perfectly fine. And I'm just going to make a plot that goes through these data points. I'm going to do the best that I can here. So I'll just go ahead and try to model it going down, and we hit this bottom point, and we go back up. So what do we call this shape? Yeah, so we call this shape a parabola. So this is a parabola. This is a parabola. And remember that we got our data points for this function from vertex form. So I'm going to make a guess here, and I'm going to say that vertex form, if it produces this shape that looks like a parabola, then I would say that writing my functions in this form is perfectly fine. So this is still a quadratic. Now, go ahead and go to number 2 and do the same thing on number 2. Make a t-chart and make a graph of that function and see what you get.